Okay, well, welcome everyone, and exciting session today for two reasons. Well, one, we're at the pointy end of this course, and you're going to actually get in and roll your sleeves up and do a mock safe system audit, but it's pretty close to a real one in a lot of senses. You'll be using a real template. You'll be going through that template and filling things out, doing the safe system assessment matrix and doing looking for some findings. We've trimmed it down a little bit in terms of the amount of time it's going to take you because certainly a full-blown safe system audit can take a fair bit of time, and we want you to just prove your ability to do that. So I'll take you through that at the end. So that's exciting. And the other exciting thing is we've got Fergus Tate here. There's Fergus on the screen. Many of you will probably know Fergus, either seen him presenting or worked with him possibly, or done projects with him, because he's been around the New Zealand road safety space for a few years and certainly been instrumental in a lot of the initiatives that Waka Kotahi has in place and that nationally are in place in terms of road safety. And Ferg is the technical director at WSP at the moment, and he has a variety of other things that keeps him busy. And we'll have a little a slide with some of his background associated with his time at Waka Kotahi, other consultancies, and doing some study in other countries and a few other things. I might ask Ferg a few questions when that slide pops up. But the reason we've got Ferg in for this session, again, a few reasons. One is his just excellent technical expertise associated with road safety infrastructure, safe system auditing, and a long history of road safety auditing, safe system assessments, and road infrastructure decision making with the optimal safety outcomes. So that's one reason. The second one is just that amount of time and experience in the New Zealand context, and knows the intricacies of government processes associated with road safety. So we're very happy we've got Ferg. Now, a few things. Ferg, welcome.
Welcome. Thank you. Thank you very much, Ken.
Good. Now, the thing we're going to see is whether you or not you can share your screen, or do I have to allow that? I think I have to make you co-host.
No, I think I can do it.
Oh,
Is it up?
look at this. Yes. Oh, and there is a lovely picture of you.
Oh, where'd it go?
Can you see it?
I can't see it, but it says I'm sharing, so it must be all right.
Yeah,
Okay.
yeah. Oh, well, I can see it. You might need to be able to see it. Technical Director, WSP, past roles there, Waka Kotahi, MWH, Opus, and then before that, Leeds University, which tell us about that.
I worked at the university as a research fellow, which basically allowed me to do my PhD fees-free, which was an extremely good arrangement. And I was very lucky to work in the road safety group for Professor Oliver Carston, and I did my thesis on an innovative junction warning system, which turned out to be a complete crock of shit. It had brilliant outcomes in terms of safety, but it had some very, very bad side effects. The idea was it was to be a warning system that if you tried to do something that wasn't right, it would give you a warning to tell you not to enter the intersection. What we found was that people actually used it as a gap acceptance aid, and they just kept waiting and looking at the warning, and when the warning stopped, they went, which it meant that their whole visual scanning pattern, which we were monitoring, changed dramatically. And they weren't looking for cyclists and pedestrians, they were looking at the warning system. And that meant that if the warning system failed, or there were cyclists or pedestrians involved in the intersection, you probably actually increased their chance of being injured. So it was a good idea, but failed at the first hurdle.
So alleviating some issues and creating lots and lots of other ones, which
Yep.
is an interesting one. So in that sort of those innovative ideas, I mean, we're jumping into a bit of content already before we finished introducing you, but I mean, safe system audits, would they assist in that sort of thing, or is it a bit too, I suppose, human factors specific?
I think that was very human factors. I was incredibly lucky at Leeds because I was the only engineer at the time in the road safety unit. Everybody else was psychologists, and I learned a hell of a lot about driver mental workload, distraction, automation complacency, and things like that. So I think what I learned was the combination of engineering and human factors creates a very dangerous engineer. It's really powerful, and the things that you see on the road and things that you know occur, the human factors can put models around that and explain why it happens. And that gives you a better understanding of what levers you have to pull to change outcomes. So I was really, really, really very lucky to be in that situation.
Mm. Yeah, that is interesting. We have been introducing this group to some sort of, I suppose, basic human factors thinking around how people might perceive road environments and the like. And certainly, as you have discovered over your career, you continue to learn as you go, don't you? Always picking up bits and pieces.
Oh, yeah. Yeah. I think when you stop learning, it's time to retire.
Yeah, that's it. That's it. Um, okay, Ferg, so I see you've got in there area of expertise crash reduction studies. So one of the things we did talk about early on here is that difference between reactive approaches to road safety and proactive approaches, and sort of putting the safe system audit into more that proactive. Tell us a little bit about your take on the differences between proactive and reactive road safety, and which you think might be better or not better, and in which circumstances?
Okay. I did some work here in New Zealand a while ago, looking at accident black spots, the things that you would look at typically if you did a crash reduction study. And I'm going from memory. I haven't got the research in front of me, but from memory, 80% of DSIs occurred at locations where there had not previously been an injury crash in the last 5 years.
Mm.
So if you're relying, and the other thing that even for those, and what you tended to find was that places like Auckland, which has the higher volumes, had the crash numbers. Southland had nothing because the volumes are typically lower. If you were relying on black spots, you would, one, not treat a lot of your crashes, but two, the other thing is that most territorial local authorities might treat anywhere from 3 to 9 if there are big black spots a year. And at that rate, to make a dent in your black spots in a place like Auckland would take you 22 years. And you still wouldn't really pick up all of it. So I think being proactive, in particularly as the volumes drop off, becomes really important because otherwise you end up chasing lightning around your network. You fix this curve, and the one thing you know is the next crash will actually be on the next curve down the road. It won't be on the one that you've been looking at.
Mm. Mm.
Having said that, you have to temper it a little bit with reactive because the local people know where the crashes occur. And they're going to come to you and say, "Why are you fixing that curve? It was that one up there that Johnny got killed on."
Mm. Mm.
And they have a perception about which one is dangerous. So you need to temper it. You need to be saying, this one actually has higher risk factors involved with it, but it hasn't had a crash. This one has had a crash. We need to think about what we're doing from the community's perspective. Otherwise, we'll end up sort of with pushback because it looks like we don't know what we're doing. So you have to really talk about the message about why you're doing the one that maybe Johnny didn't get killed on, and why you're going to do that one next or whatever. But you need to, it needs to be a combination, or you need to take, while proactive is certainly the way to go in low volumes, you need to temper that slightly with reactive.
Mm. Yeah, good. No, thank you. Now, what are you going to talk to us today about, Ferg?
Okay, right. Today is going to focus on the safety auditing component of the safe system assessment audits. I've got a little bit in there. I was just going to start, I think I was having a look. and things. We're going to look at the difference or understand the combination that's there of the Safe System Assessment Framework, which I understand you've already talked to people about, Ken.
Yes.
So
Yep.
I won't go into the framework in detail and how to do it, and we'll look at the traditional safety audit. I want to start off by talking about drivers' expectations and some stuff that I picked up from the States years ago, which I think is a really good into this, and then look at key failings. The things that I'm looking at in that list are things that I think are important, particularly curves, where I think 30% on a typical New Zealand network, 30% of DSIs occur on curves. So it's a big ticket item.
Yep.
But then the other ones that I've got in there are things like design vehicles, which come up time and time and time again in audits. So while curves are a big crash item, design vehicles and issues with them come up time and time again in audits, as does site distances. And then we're going to talk briefly about some of the detailed design stages and then prompt lists, because people play down prompt lists, but I actually find them incredibly useful, particularly when you're starting out, because they save you time and money. So that's where I'm heading with this. So it's things that I think are associated with crashes, things that come up regularly. I mean, we haven't got time to sort of do the whole rural road design thing in an hour. So that's what I'm focusing on.
Yeah. Well, this is good, and we've got people, lots of people in the chat who will be asking questions. I'll be reading that and monitoring that, Ferg, and jumping in to ask questions as we go. I see even at the moment they're answering questions themselves from the group. DSI is, yes, death and serious injuries. So yes, any clarification questions, pop them in. And of course, any other questions you'd like Ferg to answer. We will have some time also at the end of Ferg's slot for any general questions, any general topics you're grappling with. And we'll have our break after Ferg, and then we will brief you up on your safe system audit that you'll be doing. We'll probably go a little bit over our half time with Ferg before we have our break, but good. We're looking forward to it, Ferg. I'll be in the background. Over to you.
Okay, well, first of all, I start off. I mean, the new Safe System Audit Guidelines came out last year before. Now I'm losing track. As part of the Road to Zero edition, and what they did was they combined the traditional safety audit that we ran in New Zealand with the Safe System Assessment Framework. So there were two things going on there, and as I said, Ken's already talked to you about the Safe System Assessment Framework. Going forward, and I'm going to focus more on the traditional safety audit. But just looking at the start, when we're looking at the audit stages, what you're typically finding is, the safe system audit stages: concept, preliminary design for audits, detailed design, and post-construction or pre-opening. And these line up with the project life cycle or the project development. And I think I have a little poll coming in here, don't I, Ken? Do I have a poll? Oh, I've lost Ken. Okay. Well, one of the things that you find is, do we have a little
Sorry,
poll
Ferg.
coming?
I'm back.
Okay, I think we have a little poll on this slide, don't we?
We should, if I can find. Oh no, hang on, gone to the wrong one.
What we find is, as we move through the stages of the audit, things become increasingly less abstract, from the feasibility stage, which is often quite abstract, through to the pre-opening or post-construction type audits, which are typically about snags lists and what needs to be done before it can be opened. And one of the questions I always ask people is, which do you think is typically the easiest audit to do going forward?
So that's polls popped up. Apologies for me fumbling around to try and find the correct one. They nearly got another question. Which do you think typically is the easiest to audit there? We've got the feasibility, preliminary, the detailed, or the pre-opening stage. People are popping their questions in. You gave them a little bit of a hint if they were listening to you there, Ferg, which is which is good. I'm going to give that another 5 seconds. Getting some good answers coming in. 5, 4, 3, 2, 1. Of course, you're not marked on your answers in the live session. Let's have a look what people say there, Ferg. Most people saying pre-opening stage as the easiest. Your thoughts?
Yeah, without a doubt. I think it goes, and it's interesting. I think the poll is quite interesting there. I think it's the pre-opening stage is the easiest because you're actually just picking up the things that are on site. It's less abstract. Design is probably the next easiest because you've got
Detailed.
plans, detailed design. You can go through them, you can check radii, you can check turning paths. It becomes harder and harder as you go to the early stages because of standard, because you're having to visualize something quite abstract and things. And what you find, and I'll talk about it in my next slide, is that in those early stages where we're looking at the concept, that's where the Safe System Assessment Framework provides us with the greatest value, I suppose, in that you're looking at the concepts. Which is the concept that is most applicable for my situation? I actually believe that when you're looking at, because what you're doing in the Safe System Assessment Framework is you're saying, how does this concept deviate from the ideal safe system? Excuse my drawing, it seems to have got a break in my purple line, but that's just because I'm not very good at drawing. But how does it line up with the safe system, and where can I make it better? By the time you get to detailed design, or in particular pre-opening, the questions you're asking yourself at pre-opening: why isn't that why isn't that drainage grate cycle friendly? Now, you can't really put that into a safe system assessment framework. One cycle grate in a big interchange isn't going to make any difference to the score, because the scoring system is quite subjective and quite broad. It will make a huge difference if you're talking about a roundabout versus the traffic signals in the feasibility stage. And in fact, in my diagram, I've tried to suggest that the Safe System Assessment Framework is actually um, um, not really at all useful beyond stage 3. I got a little bit of a kicking from somebody in the agency when I showed them that. And they had a very good point that they were raising, was that they still wanted safe system assessment frameworks done at the end of a project, because they wanted to be able to show the degree to which the project that they had just finished complied with the safe system.
Yeah.
It wasn't about what you could use the safe system framework to improve. It was then as sort of proof. Now, whether that needs to be at stage 4 or stage 3, I don't freaking know, to be quite honest. But they want something at that point to say, we actually built this thing and it's moved from here to here. And I think, Ken, you were showing me some data some time ago about the impact of safe system assessments, and the fact that when you get those scores down, there is actually a discernible difference in DSIs that we can take from that. So yes, I suppose I would always question a client whether or not they feel that they need the safe system assessment part of the at stage 4 at pre-opening. But I know a number of clients do, because then they can say, this shows how well we've done. And that's, sorry, Ken.
Oh, well, it sort of links. Well, it doesn't. Max has asked an interesting question. I was debating whether to ask you it now or right at the end, but it's around the new government and changes you expect with their policies around safe system audits. And maybe, I mean, it is associated with a little bit of that validation of safe system compliance, which you're sort of talking about. Now, I suppose this is one you could talk for hours on, but any immediate thoughts on that, or you want to come back at the end?
How un-PC am I allowed to be?
Like, do you want me to pause the recording?
I don't think they give a shit about safe system audits,
Mhm.
to be honest. I mean, one of the biggest factors that you'll find has a major outcome in safe system auditing is speed.
Yeah.
And managing speed and managing crash forces, because that's what we're talking about, a safe system. And the evidence from the latest GPS is that does not appear to be much appetite for large scale speed management. In fact, I think it's page 19 that says that safety money shall not be used for traffic calming and the use of raised safety platforms.
Mm.
So I actually read that and came away feeling quite depressed, to be quite honest.
Yeah.
Um, so, um, so I think, it would be good if we had safe system audits that said you need to manage speed, because that's all singing from the same song sheet. But whether it'll make a big difference or not, I really don't know at the moment. I'm feeling quite disheartened.
Yeah, yeah, as many people are. But I suppose there's a couple of quick points on that. One is there's always government changes, and we've got to get used to that. And if you've got a long career, you're going to get government changes. What is good often though is that when you have entrenched something into policy, it becomes somewhat hard to unwind in a one election cycle. So take, for example, safe system auditing, that they won't be able to stop that policy, or it's probably not on their radar to actually stop the process of somebody undertaking safe system audits on projects. That will continue, right? I think Ferg's point's a really valid one. The any recommendations, any suggested changes may be harder for the organisations to actually implement because they uh, often naturally have these speed management components to it or other things. But it shouldn't stop us as safe system auditors from putting that down on paper. I mean, it's not for us to make calls on government policy or anything like that. We're simply trying to give them the ideas of the safest outcomes, and then they can grapple with the different policy challenges that they face.
That's much better said than I said, Ken. Thank you.
All right. Well, keep going. But thank you for the questions. And one, just a clarification for Tim. Yes, black spots being those areas of concentration of DSIs. So that's correct. Yeah.
Yeah. Okay. Just some guiding principles. These are a series of quotes that I actually think are worth having a. I don't like saying you can read the slide yourself, but I'd like to read it out, because these are really quite important quotes that I took from a Federal Highways publication back in the 90s. It says, generally drivers make fewer errors at geometric features that conform to their expectations than at features that violate the a priori or ad hoc expectancy. So what they're saying is, when what you see is what you expect, you don't make as many mistakes. And then it follows, if a road is consistent in design, then the road should not violate expectations and inhibit the motorist's ability to control their vehicle. So if you've got good design, then you'll get fewer geometric features that don't conform, and you'll get fewer errors. And then the final one, consistent roadway design should ensure that most drivers would be able to operate their vehicles at their desired speed along the entire alignment. So really, don't trick and fool drivers or trap them. And I think one of the things that comes up time and time again in our crash data is that the driver was traveling at an inappropriate speed. And one of the questions you always ask yourself is, how did they actually know what the appropriate speed was?
Mm.
Particularly if you've slipped a little banana skin in there for them and it's just caught them unawares, they think that the speed that they're doing is appropriate because of all of the signals your road environment has sent them, that they should be doing it, that they can safely do 106, and suddenly they hit a curve which is 50 kilometers an hour. It's violating their expectations. It's increasing the likelihood of the errors. And while the police record would say the driver drove at an inappropriate speed, the question really is, what the hell did the designer do in the signals that they sent to the driver about what was appropriate? Now,
Yeah.
as I think I said earlier on, the big one for many networks is curves. Um, and things Curves, I mean, any clown can drive along a straight road. It's the curves, and we find that 30% of our DSIs, typically on state highway network, are on curves. So they're a big ticket item out there. And there are two sort of things that impact the likelihood of drivers making a mistake. The first are curves that are difficult to read, that it's hard for drivers to actually perceive them. And the second is out of context curves. And I'm going to talk about both of those, but I'm going to start off going back to uni or tech or wherever you did it with the mighty curve equation, which says E, which is super elevation, plus F, which is friction. Those are the resisting forces. They resist the loss of control forces, which are based on V squared, velocity, over 127R. Now, my question to you is, in the poll, which of these things has the biggest impact or the most influence on curve negotiation?
Okay, so just recapping there, E is super elevation, F
Yeah.
is friction, and we've got V velocity and R being the radius of the curve. Now, as people pop their thoughts in there, I can see people scratching their head at the moment. I can't see them, of course, the camera's not on, but I can imagine them scratching their head. The term out of context curve, I first ever heard that quite a while back in New Zealand. I don't know if you were in the room or others, but is that something that New Zealand came up with, or just the term out of context curve, or did you pick that up over in the UK or something?
I don't think so. I think it was actually something that Colin Brodie and I were associated with when we
Yep.
were looking at the friction levels and at the and at this type of stuff. I mean, basically, you know, if you've got a 70-kilometer an hour curve in a generally winding, tortuous environment, it
Yep.
doesn't have the same number of crashes as if that 70-kilometer an hour curve was at the end of a long straight.
Yep. Yep.
Because in one situation, it's in context to those driver expectations. Everything about the environment tells me that I should expect this curve,
Mm.
and it's not violating my expectations. And the other one, I've driven a long straight, and holy shit, at the end of it, there's a dodgy curve. And guess where people fall off? Because one of them is violating the expectations and one of them isn't. And we sort of thought, it's the context.
Yeah.
Is this curve in context or is it out of context? And that's how we sort of came up with, and we then looked at the degree to which, and I've got some figures coming up, the degree to which you're out of context.
That it is one of the terms. Like, I have a handful of terms that I think are just so beautifully worded in road safety engineering. Out of context curve is one, because it just beautifully encapsulates what we're talking about. A couple of others off the top of my head: trap lane. I think whoever named that deserves a prize. Also, dilemma zone. Signals dilemma. These to me, they just make me happy in just the wording of them, so people immediately understand. And out of context curves goes into that as well. All right, we have got lots of people having guesses. I'm going to end the poll now, and
Okay.
I'm going to share the results there. Now, most people are opting on V velocity, so the speed. People are going there. And a few for R. Maybe seeing that 127 in there. But V, what do you reckon, Ferg?
Okay. V is the thing that's most important when you're coming off or going into a curve or coming off a road on a curve. But V is actually a function of R. Drivers don't see super elevation and they don't see friction. They certainly can't see friction. They could possibly feel super elevation once they're in the curve, but not typically very well before the curve. And so their V choice is based on what they can see, which is radius. Now, one of the problems that we get is that there are a range of curves for which the radius is actually quite hard to read, and these are the difficult to read curves. So I'm looking, oh, I went the wrong way. No, I didn't. Yeah, difficult to read curves. So this is a bunch of data that was collected by Shane Turner and myself, looking at the design speed of a curve and the radius of the curve. Now, drivers use the radius to try and make their speed choice. But for a 300-meter radius curve, it could, in a compliant curve on a road, have anything in terms of a negotiating speed, a design speed, from 60 to 100 kilometers an hour. Now that's a hell of a difference. So when I look at one of these, how do I know it's a 60 or how do I know it's 100? And these curves are difficult to read in this area. You know, you don't know what the design speed is, so you don't know what the appropriate speed to negotiate them is. Now, if I look at some data here, this is the same data, but plotted from the same experiment, but plotted differently. It was 488 curve negotiations. This is the minimum radius of the curve, so between about 450 and about 250 is this range in here. If you look, this is drivers on large radius curves treating them effectively like a straight. They've got very high speeds. Even as we come down under 450, they're still traveling at reasonably similar speeds to the straight. It's not until they get to 300 or maybe 250 that their speeds start to drop off when they see the curve. And if you think about it, that 300 curve, I think it's a straight. I think it's a straight. I come into it and I don't know if it's 100 or if it's a 60 in terms of its negotiation speed. I'm typically going to be up in this area up here. And that's why those curves are typically considered hard to read. There's some very good work done by Steve Levitt out of New South Wales a few years ago, where he was ranking curves, and his highest priority for treating curves in terms of barriers and treatments in general were the 250 to 450. Some people say it's 200 to 500. Some people say it's 250 to 600. It's in that range. In there are curves that we generally want to stay away from because drivers typically have trouble reading them. And if they are having trouble and you do have to have them, then you have to do something additional at that site to help them understand what it is that they're about to negotiate. So that's really important. So these are the curves that are hard to read. And again, looking at the 85th percentile speeds at a 300 radius curve, anything from sort of 110 to 95 in there, it makes a big difference. You can see with the 85th percentile speeds, it's actually even more pronounced, this sort of straight effect, and then suddenly at around 300, she starts to dive away. So that's the difficult zone.
So maybe I'll ask a question then to the group before we jump too much further on. For that difficult zone, what do people think might be ways to lessen that risk? We'll see what they come up with. And Juliet's asking, do we have any images to show what those radius curves look like? No, we don't have any in this presentation. I might, while Ferg's doing that, try and dig out a few. It's a good it's a good question, just so people can visualize sort of what is a sharper curve compared to a less sharp curve. Thanks for that, Juliet. I'll see what I can dig out. So we've got advisory speed signs, chevrons, so cams, chevron alignment markers, advisory speeds, advanced warning signs, different advanced warning signs. Oh, we've got somebody's popped in rumble strips on the approach to the curve. Electronic warning signs, possibly vehicle activated style signs, barrier systems. So looking at the severity of the incidents that occur, ideally realigning, so big bucks there. Otherwise, shoulder widening barriers and signage, chevrons and the like. So anything in that big list there that really pops out in your mind?
Well, I think the standard ones are your signing system, and New Zealand actually has a reasonably good system based essentially to how those curves line up in terms of their context, which I'll talk about next. The one thing that seems to be missing from the discussion is friction. I've said people can't see friction, but it's vitally important. If I go back to the equation that I had up here, you could stick some more super elevation on a curve and take it from, say, 0.09 to 11%, which is 0.11. So you're playing with digits around 0.01, or you can change the friction from 0.4 to 0.5. One of those is 10 times more powerful than the other one. And what we've certainly looked at in a number of situations, somebody talked about realigning, you're much better in terms of your dollars spent maintaining a higher level of friction on those curves than you are realigning them, on top of the typical signage that you should put in there. And things. And we get some very good results from speed activated curve warning signs. There was a very good thesis done by Steve James from Waka Kotahi on the impact of speed warning signs. So he's worth at Urban Connection. He's worth having a chat to if you're interested in that space. He's done some good work in there for his thesis. The other thing that I think is really important when we're coming to it is the length of the curve. If it's a shorter curve, or like a kink in the road, it's easier to flat line, and it's easier to basically get through. The longer the curves are, the higher the crash rate. Mainly because there's more length of curve to crash in, and we're talking about crashes per curve, but it's harder to flatline. And if you make a mistake on entry, it's much harder to correct because the curve is long and you're stuck with your decision effectively. So again, long curves in that range are even worse. I don't want you to go in that range, but sometimes we have to, in which case make sure that they're as short as bloody possible so that we don't run into problems with them. So that's curves that are hard to read. And then how you actually place the curves is also important. One of the things we should try and avoid are similar horizontal curves in the same direction that give a broken back alignment, unless they're sort of separated by a couple of seconds of travel time. These ones where you go into a curve and then you have to have another bite of it and go again, and particularly if the bite is an even tighter radius, that can trap drivers and things. But looking at where we place things so that we don't end up with little curves or kinks or railway lines in these dips where you can't see. What you're really looking at is trying to get a smooth flowing alignment where people can see so that they don't get trapped by things falling outside their expectation. I mean, if I going back to this one, who knows? Would you expect a railway line in this hump from what you've seen? No, so you've violated the expectations. If that railway line's on a curve, God help us, that really is a trap for motorcyclists, because there's nothing with less friction than a nice wet steel rail partway around a curve in a hollow. I mean, if you can see it, Ken, you're the motorcycling expert, really. But if you can see it, you can adjust your behavior as best you can. If you can't, then it's all over.
Yeah. And I was just actually to try to assist Juliet there was I'm going to steal the screen for a second here.
Yep.
Because I think I've got a couple of curves sort of sitting in that range that we're not happy with. And this is part of a motorcycle presentation I'm getting ready to assist the Tasmanian government with actually. But it's funny you say that. So are you seeing my screen
Yep.
there, Ferg?
Yep.
Yeah, so you can see that sort of that curve radius there, which is a sort of 55 radius. It does sort of sits somewhat within that, a little tighter than the one that's completely out of context, especially in amongst all those other curves. But this one here really, what is, and you can't even see the curve over the top, is particularly hazardous for riders, just in the sense that they don't know what they're coming up to, and then all of a sudden it's out of context on them. So that's they're the sort of ones. And then I do have just another couple of curves. So just this one is a showing a 252 radius into a 117. This is a compound curve. So Ferg sort of mentioned broken back curves. Compound curve being sort of those two radiuses, a larger one into a tighter one with that kink there. So that was that one. And then I'm just going to go forward a few perceptual countermeasure studies. So that will be a tighter curve. So this is more sitting in the lower one where the people would be more aware of that radius of it. So I think there are just a few to show you, and I'll let you take the screen back there, Ferg.
Okay, so try again.
Sorry.
Okay, we're back again.
Yep, gotcha. Yep, we're back on that slide. Thanks.
Okay, so getting the coordination so you get that smooth flowing alignment where you've got you're giving drivers continual clues as to what they may expect coming forward will get your crash rate down and things. The other thing that you got to be really careful about is design by CAD or by roads or by 12D. My friend Keith Wheel once showed me an alignment where in 800 meters there were 6 different vertical alignment components. That's just a complete nonsense. You might think you're balancing your cuts and your fills and everything else, but by the time you put a compaction factor in there, getting something to within a few millimeters with a different type of alignment is a complete and utter nonsense. So try and think about the big picture, which is to get this flowing alignment that's easy to do. Now, the next one is we've been talking on and off about out of context curves. This is some research that we did that talks about the difference between the approach speed to a curve and the crash rate per curve. So if the difference, and this was typically using 100 km/h curves. So when you're down and the difference is about 10 km/h, the crash rate is about 3.5 per curve. It's actually per vehicle entering a curve, sorry. When you get up to about 20, it goes up, it doesn't quite double. And when you get up to 30, you can see it takes off. Now, this is an interesting arrangement because if you think about how we signage curves that are out of context, we typically just put a curve sign in if it's 10 kilometers out. We put a little advisory speed, typically if it's 20, so we'll have the normal curve sign with the advisory on it. And then when it gets up to about 30, you've got the full chevrons with we call them the PW67s with the speed value on the front of the 4 chevron board, and then the chevrons all around the curve, and that comes from some research that Sam Charlton at Waikato University did, where he found that the number that you actually put on the speed advisory was not as important as the size of the advisory, if you like. So drivers recognised that 4 chevron board with 65 on it, and the chevrons around the curve did almost the same speed when it actually said 85 on it, because they knew that having that full drama of signage meant that this was a tight curve. And obviously, as the out of contextness increases, it goes it rises rapidly. So trying to stay away from curves, and this is per 100 million vehicles entering the curve, was the curve crash rate. So it's not just about the length and the angle of the curve. It's the degree to which it's out of context, and that's really important. One of the things that often comes up when you're dealing with curves is that we tighten them up and we do them up. We make the curve, we improve this curve, and all that does is increase the speed of traffic into the next curve. And at some point down the road, you'll exceed the scope of the project, and you'll find that when you say, well, you need to look at what you're going to do on this curve, and the project manager says, no, that's outside the scope of the project. You don't have to worry about it. Your project will be increasing speeds into that subsequent curve. It will increase the likelihood of death and serious injury, and it should be part of your audit, whether it's inside the scope of the physical works, it's impacted by the physical works. And what we typically find is our projects continue and continue until the going gets tough and the dollars start to increase. So what you'll find that you'll make the passing lane or the crawler lane longer and longer and longer until you get to a vertical bluff that's going to cost you a fortune to cut back, and so suddenly you end up with your realignment finishing just upstream of a 70-kilometre-an-hour curve. What you've done is you've actually created this. And so you're going to migrate crashes to that curve, and you need to look at it going forward. And it's really interesting. We did some work for Austroads a little while ago. Almost half of the passing lane installations in New Zealand resulted in an increase in crashes when we looked 2 to 5 kilometres downstream. And that's because what you're doing is you're increasing the speeds through the passing lanes into what is really a substandard environment and getting this crash migration. So when you're doing your audits, you have to look downstream to the point where you're not getting changes in speed. You know, Ken often asks me, where do you stop? But, if you increase the next curve and that's running the speed increase into the next one, go back to this graph. Where you're not changing the speed environment by more than 10 or 20, and you can get away with signage, that's the point where you stop. But you need to keep going downstream because your works are what's creating this road hazard going forward. Anything, Ken?
Max has just put in a good point. I had said earlier in the course about us doing this safe system assessment and the reasons for its integration into the safe system or audit as such, to ensure that we don't just see those audits coming back which say, put up a warning sign or the like, where we're not actually fundamentally addressing the issue. But he's sort of rightly pointed out these scenarios are probably ones where we do see a lot of benefit from correct signage. Yeah, I was probably more talking in the context of some of those maybe high-speed crossroads and those sort of things where you've got a very significant issue and a warning sign really is not going to do it from that perspective. This one, we also have a significant issue, but correct and appropriate signage is good. The other thing in here is a question around, did those passing lane benefits exceed the benefits gained at the project location? So
Who's this?
That was Max again. So
Okay, Max. oh, damn. I've actually got another whole presentation on passing
I know,
lanes.
because you did that Ostros project recently, didn't you?
I did.
Yeah, yeah, yeah.
Basically, the benefits at the passing lane location are typically very small. The benefits of passing lanes are really, in terms of travel time and congestion of impacts, are more about going from releasing a platoon of potentially frustrated vehicles and letting them release, and then the benefit lasts long beyond the physical length of the passing lane until effectively that traffic replatoons to that sort of level again, and the same levels of frustration arise. So a passing lane, 800 meters, it's typically been argued that frustration benefits continue for up to 5Ks downstream. I think that was Glenn Curry's research. What this was finding was that downstream we were getting these crash increases. So the idea that you actually get crash reduction benefits from reductions in frustration downstream of passing lanes was completely negated by the data that we found that said that we were typically getting increases in crashes. The reason we believe we were getting increases in crashes was because the downstream geometry in most cases was not capable of taking the increased speeds that you get off the interpassing lanes and things. And New Zealand had a policy uh, developed by Larry Cameron to put passing lanes in depending on volume, and I think we shoehorned them into situations where I think looking at them now, we should probably never have put them because their end effects were so poor.
Yeah, and I read that Australia report over the Christmas break actually, which was good, and it is quite a well put together document. So I'm going to put it into the learning management system in the resources so anybody can have a look at it. I mean, you can find it on the Australia website, but I'll pop it in there because it's worth a read for those interested. Thanks, Ferg. Let's keep going.
Okay, let's keep going. So downstream crash migration, we killed that. I'm just looking at out of context curves. This is some data from something called Blueberry Curves in Whakatane. Have a look at the crash data. What's it telling you? Whoa, we got a bunch at this curve here near Powdrill Road. And they're all on the curve. They're all loss of control on the curve. And then we have a look. Now, what I've done here is I've plotted the geometry every 10 meters from the high-speed geometry vehicle, the vehicle that drives our state highways every Christmas, or from sort of October through to March. And this is this curve here. And what I've plotted here is the crossfall or the super elevation in orange. And I've plotted 1 upon radius. The reason I plot 1 upon radius is that a straight then lies along the zero axis, and the tighter the curve, the further up you go. Now, what can you see at this curve here? You can see that halfway through the curve, the super elevation drops off dramatically. That's not something a driver's going to expect. Also, when you're traveling in this direction, which is where most of the crash is, you come into the curve, it suddenly flattens, and then it tightens up real tight, which is what that's telling me there in the blue line. So I'm coming along, it's a gentle curve coming in, it flattens out, and then holy crap, it's tightened right up on me, and that's the consequence. Those are the crashes. There we are. So it is, while I talk theoretically about this, this is all driven by crash relationships, and looking at the geometry and things, particularly if you're doing reactive work, looking for things where the super elevation drops off. This often happens when you go from cut to fill to cut. Over time, the fill drops a bit, and you get flat spots. But the other one to really watch out for are these curves where you're coming in at one radius and then they tighten. Coming in at one radius, it's only short at that radius, but suddenly it tightens. And Ken was showing you those curve tighten signs. We haven't had much traction on those in New Zealand. and things, but they may be something. I think that when they were looking at them some years ago, people didn't really understand what they meant, and so they didn't go much further. This is a much better one. Again, it's coming in, it's tightening, and then it's tightening again, and the tightening again lines up with the drop in super elevation. So all of these are going to trap drivers because their expectations are that they should be able to go around a curve that looks like this, not that, and that they will have certain amount of super elevation going through. So those are the things to watch out for. Right, I'm going to talk about design audits. And things, because they're the next hardest, I think, in terms of the harder one, about the sort of things that you need. Crash history shouldn't drive a road safety audit, but you should be aware of the crash history, particularly if it's an improvement, to understand what it is that's trying to be addressed by the improvement and what sort of things are likely to happen. We need to be aware of who's going to use the site and for what purposes. And we'll talk about design vehicles in a minute. But again, you'll find that regular users have a different pattern of use to tourists or one-off users who don't know that just hidden over that crest is a bloody railway crossing, and who are possibly looking at the scenery and don't see the railway crossing sign. But we do need to. Oh, sorry, you got something to say, Ken?
I was just going to address Ash's question that had just come in. It was more related to some of the data you were showing and data that we would look at and interrogate as part of a road safety audit. And probably the data you were showing there is far more precise than we would be looking at in any audits. If you are given different skid resistance data and the like and elevation data, but more from the audit perspective, you get a feel for that if it's an existing road by driving through it and getting that feel. And also, if it's a design, you can sort of look at that from the geometrics of the design.
Yeah, one of the things with the audits, particularly tightening curves, if you're driving through, watch the drivers, if you're the passenger, watch the driver's hands. Watch them if they're taking bites or flattening and biting and flattening and biting. They'll tell you if they are, but you can get a lot from just watching their hands and how smoothly they're going through the curves and things. And the interesting thing is that while the design may be fine, what drivers use is the road markings.
Yep.
And if you think of how much precision we put into design, have you ever seen the road markings go in?
Yeah, not as precise as
They're not as precise as you might think or what you might want. And I have actually had a problem curve, which we did a crash reduction study on, where what we did was actually recommend that they go out and survey in the edge line, because over time the edge line with flickies and whatever had actually moved. We moved the edge line at its worst position about 400 mils.
Okay.
And it made a huge difference to the drivability. I think even it was moved a couple of 100 mils, it got rid of the double bite.
Yeah.
We got a single curve in there. So, while the design may be, it's when you're doing that post-construction and Mr. Crap Roadmarker's having a bad day, he can probably make, and I can tell you a story that I'm not particularly proud of. In the old days, we used to rope the curves for the edge markers. Before flickies, you used to go through and measure offsets and put marks down and then get an enormous piece of rope, 90 meters long, and curve it round the curve through your offset marks to make the line, and then put dots, and then the spray truck would follow it. One day, on a job that I was doing, in between when we'd measured the offsets and we went to put the markings back, a car lost control and took out the fence that we'd measured the offsets from. And we had no idea where to put the offsets back in on this reconstruction. So we got the rope, and it was a long curve. So we did it from one end as far as we possibly could with our rope, and then we did it from the other end as far as we possibly could from our rope, and we created a broken back curve. And that actually turned into a black spot very, very quickly.
Right. Incredible.
And
Yep.
I wasn't particularly proud of myself for doing that.
No.
And yeah, so we then actually had to go and survey it in on the next reseal and get it all tidied up. But
Yeah, yeah. Well, and just to clarify Frank's comment there, so flattening and biting is really as a driver turns, and then they'll jerk to try to correct themselves. It's not that smooth, one nice consistent
yep.
drive around. So thank you. Let's keep going, Ferg.
Okay, sorry. So we're looking at who's going to use it, particularly pedestrians and cyclists. We're going to look at previous audit reports to see what they've put up. One thing that comes up time and time again that people ask me, in the previous audit report at the feasibility stage, we said that this was something about this was bad, and they haven't done it, and they've told us that they're not going to do it. Should I mention it again in the next stage audit? Yes. Just keep banging the bloody drum. Because at the end of the day, you've got the courage of your convictions. If it should be a, if it should be a 500-meter curve and they're only going to 400, and you've said it once, you can say it again in the design. This would be better. The safe system assessment will tell you the same thing. Don't just say, "Oh, the client decided last time, therefore it's out of scope." Have the courage of your convictions going forward. Heavy vehicles. Heavy vehicles come up time and time and time in audits. And in fact, I'll talk about something a bit later on when it comes time about a recent example that we've had. But who can tell me the difference between a design vehicle and a check vehicle?
All right, we'll see what people pop into the chat on that one. And we've probably got about half an hour left at most, okay? Just to flag
Okay.
things. I'm enjoying the discussion, which is always fun. Let's see if anybody puts in the difference between a design vehicle and a check vehicle or a checking vehicle. No, we haven't. Oh, here we go. Here we go. Check vehicle should be able to get through at slower speeds. So sorry, a few are coming in now, jumping up my screen. Design vehicles during the design phase, checking vehicles after construction. Not sure about that one. Design is what you expect to typically use the location. Check vehicles more for one-off users to ensure there are no issues. I like that one from Ash. A few others coming in. Ferg, you happy with Ash's one?
Yep. I think the big thing is
Give Ash a prize for that. I think Max was there as well. And a few others coming in as well. But we'll give Ash the prize for that one.
Yeah, so the design vehicle shouldn't encroach on the shoulders, the footpaths, the adjacent lanes, whereas the check vehicle should just actually fit through if necessary with small encroachments. Now, the choice of design vehicle becomes really, really important because not every bloody piece of road has to have a quad axle semi go through it. But on the other hand, if you're on a rural farm road with tankers, then you're likely to have tankers which are going to be quad axle semis. So yes, it's important, even though the volume could be very, very low, that they can take those. And then the design, the check vehicles, are the one-off heavy haulage and things that are going through. Where it becomes really important is when you're talking about, or I find, is the right choice of design vehicle. I've just seen a design for a bus route, and we're going to talk a little bit more about buses in the next couple of slides, aren't we, Ken?
Yep.
Where it will take a quad axle semi all the way through, but it won't take a 12-meter coach. And everybody goes, well, why is that? But you've got to remember a semi has got an articulation point and a coach doesn't. And a coach has got a very big front and rear overhang and swept through. So knowing what it is and not just assuming that a 25-meter B train will get you through, therefore anything can go through, is something to be very, very careful about. So choosing the wrong design vehicle is a common issue. The other is that swept paths are always plotted using a speed. And you need to know what the appropriate speed assumption is. Because if you find, particularly if a vehicle is moving from lock to lock, so turning hard left and then hard right to make the maneuver, that's easily done at low speed because there isn't much drift. But as that speed goes up, those swept paths get larger and larger. And the number of times that I've found that I've got an open road site where you're expecting a vehicle to make a slip left turn, and suddenly you find that they've used a 5 km/h turning speed, and you know that it's going to be a minimum of 30 and probably 50 km/h. Go back, draw it. Oh shit, it doesn't fit. So always, if anybody shows you swept paths, ask them what the speed assumption was that they were based on. And then ask yourself, is that real? And if not, tell them to go back and do it at one that you think is more appropriate.
I think a few people are just trying to get their head around some of this. So I think some diagram examples of swept paths is going to really help people understand what we're talking about there in terms of what is a swept path, and that is that area which a larger vehicle sweeps around that's not on its exact wheel tracking line, which we'll see in some examples shortly. And then we'll delve a little bit further into some of these specifics that Ferg's talking about with some examples. Always easier with examples, but let's keep going.
Yep. Okay, we'll keep going. So, and the things that you're looking at for the swept path are things like encroachment into the opposite traffic lane, encroachment into pedestrian areas, conflicts with other vehicles at the intersections, and roadside furniture, particularly with the check vehicle. The design vehicle shouldn't get anywhere near roadside furniture at all, but the check vehicle may get close and you need to be careful. So as Ken said, we've got some examples. So here are some turning paths, if you have a look. So this here is a semi-trailer, a 25-meter semi, and when it drives around, you'll see that the swept path is far bigger than the vehicle itself, and that's the path that it sweeps from its outside mirrors or body, usually plus half a meter. From most software will do that. In here, we've got two going around together, and the recommendation from Ostroads is that you should have a meter clearance between them as they come around and make this curve. And in the old days, we used to do it with pieces of plastic with paths marked on them, and you would hold them over your drawings. Now, thanks to the wonders of CAD, you can just slap them on and put them there. What that does mean, though, is people do all sorts of weird and wonderful things with swept paths to make them fit, and some of them don't make any sense at all. So this is a swept path here in a job in Auckland, looking at what's going on, coming around here, around here, around here. And you don't always have to have two B trains next door to each other. This is going to an industrial area, and so we're using a single unit and a B train and a quad axle going around here. But you'll see these get very, very close together on some of these curves, and that's telling you that you've potentially got a problem with them clashing. But this one is the one that's of more interest. This left turn, which is on a give way, he cannot actually stay within his lane to do that. Now, this is a signalised intersection, so it may be possible that this vehicle actually waits back here and goes only But I would be suggesting, if this was the case, that this be signalised, so that you avoid the option of this vehicle coming around at the same time as vehicles are coming through and they get trapped in this area here.
Yep.
So I would look at signalising that turn so that you can avoid the conflict, because clearly there's going to be a conflict because he can't stay in his lane, or she can't stay in her lane, going round.
Yep.
This is an example of crazy tracking paths. This purple one here, I drive a bus. Well, I used to drive a bus. I don't drive a bus anymore. But there is no way that I'm going to drive a bus and do that little turn, then go straight and then do another turn. That will be all one maneuver for me, and it will end up encroaching in the other lanes, because to do this maneuver, you've got to do something that isn't naturally intuitive to the driver. They've got to know that to get between this point here and that point there, they have to be in a particular position down here and do some sort of convoluted double turn. This is actually going left, then slightly right through here. Sorry, going right and then slightly left through there, and then going right again up here to get through. And that's a very difficult path to drive and would actually end in conflicts. This one down here, coming around here, big swing out, right over to come back round to get through, because that trailer width is so large going across that intersection.
Hmm.
So yeah. Oh, I forgot that one. This one here, going around here, going over the curb. This is where the pedestrians are standing. So going over the curb, wing mirrors encroaching on the curve area. Buses, there was some work done by Frank Lye a few years ago on bus incidents in the UK. The most common incident was being struck on the head when you were on the footpath by the wing mirror of a bus. And people do, they wait here, they wait on the tactiles or wherever they are, and then something over strikes, and it's on the left side, so they're not really seeing it, and hits you in the head.
So that links a little bit with the Min's question, which came in around the 500 mil tolerance that's added there. And for those not sort of familiar with that, you can sort of see there's two lines on the outer, which is so you got your wheel tracking is the dotted, and then you got your swept path, and then a tolerance there. Is that
Yep.
do you feel that 500 is excessive, or is that trying to cover off those wing mirrors and other bits, or a little safety factor?
It is, and then you expect, if you got two opposite each other, the Austroads guidance is for 1 meter between those two outer envelopes.
Yeah.
But it is to give you a safety factor in there.
Yeah. Okay.
This is one of Ken's, but this is a bus depot in Melbourne.
Ballarat, actually.
Ballarat.
Yeah.
Sorry. So this is a bus depot. What do you have at bus depots? You have buses, and you have people that want to catch buses. So why on earth would you design a swept path that goes right through?
Yeah.
And that's the body swing on that coach, is going right through that area. Now, if you were a visually impaired pedestrian who has a higher likelihood of being on a bus because they can't drive, and you would be standing by those tactiles, and because you're visually impaired, you've probably got no idea that the bus is about to take you out because you feel safe at a bus depot. But no, this is a shocking design. On the wrong way, I think, yeah, in this area here.
Yeah.
And it gets a bit close over here too when you're looking at the two paths for the buses coming in and out. So, we've got to be really careful looking. And this is, you probably find you can get a quad axle, an Arctic round there, but not a bus, because buses have the much bigger forward and rear distances on them.
And it's funny you say that, Ferg, that in this one, often it comes down to some constraints people had. They had a number of car parks that they had to put in, so they couldn't. So they were pushing their boundaries on car parks. And the first design that came in for auditing had the quad axle semi as the design vehicle, which fit around that location. And that's where sort of the auditing process, stepping back and questioning their actual design vehicle choice and saying, well, hang on. I mean, this is a bus depot. You have to use a bus as your design vehicle if it's going to be worse in that sense. So yeah, another example of where auditors are assisting with these checks on spare parts.
And most people don't understand that buses are actually coaches as opposed to buses, I suppose. Coaches are a much more difficult vehicle to accommodate in urban areas than something with an articulation point. This is another one in here where we've got conflicts in this area here. So exiting bus and entering bus can't actually pass each other. This is a one from Masterton. It's a bit hard to see in these colors. I'm not sure if I've got it, but this is an interesting one. In order to actually make this turn here, the vehicle has to change. Oh no, this turn here, sorry, this one through here, around here. The vehicle has to go from hard left to hard right lock. Now, if you're doing that at 5 kilometers per hour, that's doable with this sharp change in direction at this point here. If you do it at 30 kilometers an hour, that actually comes way the crap over here and is far smoother, and you end up hitting the island. So knowing what the negotiation speed was at these drawings, anywhere where you get this sort of picture of changing lock should ring alarm bells. The other one that you see in this one here is the expectation that the driver's going to go in here and out and around. They're not going to do that. They're going to cut through there and end up in conflict in this area here. So you just need to have a little bit of a think as you go through. This last one is about what I call driver's view. If in this picture here you are parked here at the give way line ready to pull out, you can't actually see back to what's going to hit you back on this curve because it's behind you. If you pull this give way line round squarer so the driver can look out their window at what's coming, they can't actually make the turn without taking out the barrier. So you need to understand where the driver is sitting in relation to his mirrors and his windows, and in order to make sure that they're going to actually sit at the place that you think they're going to sit. And in this case, they won't. They'll sit squarer here so they can see, and then it makes it very difficult to turn inside that barrier. So, look for evidence. These ones obviously not doing it so good here. This is a beaut in terms of tracking through there. Obviously, the impact on infrastructure. And the last one I was going to look at is sightlines. Do you know how many different sorts of sightlines there are in the Austroad standard?
There's a lot.
There's a lot. I can't.
So, yeah.
I should actually count them up and make a poll, but typically the other users, the pavement, the things, understanding what the sightlines are and what constitutes adequate sightlines comes up time and time again in audits. The big one is often for side road entry. Safe intersection sight distance. So you're sitting back, you're looking at the vehicle coming down here to identify how big a gap that you can go out into. If you can't provide that, then you have to provide safe stopping sight distance, which is the sight distance from here to here that says that this vehicle will stop if this vehicle pulls out. That's effectively changing the priority of the intersection, because what you're really doing is you're requiring the vehicle who's not expecting to have to stop. And then the classic that I've seen is they've said, because it's an urban area, this safe stopping sight distance, I only need 1.5 seconds of reaction time. because it's an urban area. But what you're saying is, I'm not expecting to stop, so I'm going to use the smallest reaction time. That's a load of rubbish. You know, if you're not expecting to stop, you need the biggest reaction time. Here's a classic, which is one of Ken's. On the side road here, that's what it looks like on site. You can see just above that Toyota Camry, there's a little white bit. That's that white bit there. So you don't actually see that vehicle in any way, shape, or form until it's pretty much on the intersection. So you can't clear here. And really, you'd need to be taking out that first car park, which always goes down badly. But that's what you have to say. So if you're looking at your sight distances, you need to work through them systematically. I won't go through them all here and things, but they're all there in the guide. And then the last one I was going to say is some of the common issues that we find around intersections, including the stand-up angle, the sight distances, roadside hazards, backs of queues. You know, you need to know what the 95 percentile queue is, and then put braking distance on the end of that to calculate where a vehicle is going to slow down. If you've got an off ramp that queues, the last thing you want is for vehicles to be decelerating on the main highway line in order to make the back of that queue, because again, that's violating the expectations of the drivers behind them. They're not expecting somebody on the main line to be slowing down to whatever. So that Danish offsets, that's for the Z crossing, so that you're turning and looking into the traffic. But against that, I've just done one recently where we did it the other way around, because what we found was that the pedestrian desire line, if we'd put it in the Danish correct version, we would have taken the pedestrians about 30 meters out of their way. And that wasn't going to happen. So we've actually kept them on their path and did it the other way around. But at least we knew why we were doing it, and we did it.
I think
So,
that I think we may have shown this group a Danish offset in the pedestrian presentation. I can't remember, but just to clarify for anybody who's trying to visualize that, that's where you have pedestrians crossing into a median, and then they walk along the median a bit, and then they cross again. And you could, if you imagine that, you could get them to walk in the median sort of either direction. What you could configure it as a Z or a backward Z if you're looking down on it, and you want to get them so all pedestrians are facing traffic when they are. But Ferg was just giving an example there where, well, yeah, yes, that helps a bit with safety, but if you're going to design it and nobody's going to use it in that configuration because they'll just walk where they want, well, we lose a whole lot of value. So you've got to take it case by case.
yep. Okay. And then when we're looking at the sort of mid-block stuff, particularly around roadside hazards, they have a real impact on the severity of outcome, and managing roadside hazards is really important. Do you do a session on that, Ken, separately?
No, well, we had a bit at the start around roadside hazard management, barrier systems, and some of the just flagging the technical nature of some of the barrier stuff as well.
Okay, but that's really important, the roadside hazard management, because it has a major impact, and it certainly comes through in the safe system assessment framework in terms of the severity of outcome lines, and really important there. Drainage, short mergers, blind mergers. There's a series of prompt lists in the back of the Austroads guides, which I really like. They come right down to detail. And are the bus stops located with adequate visibility and clearance of traffic lanes? After you've been using them a few times, you'll just think of what are the public transport issues. But it's really important, particularly when you're new to this game, going out and taking the prompt list with you. There's nothing worse than getting back to the office and going, did I check the service coverings? Were they in the middle of the traffic lane for motorcycles? Oh shit, I've been through all my photos. I can't see. Oh damn, I've got to go back out, and it's an hour out to site. Do the prompt list. It'll help save you time in the long term, because you won't have to make returns. And that reminds me of something which I should have been saying: photograph. Photograph, 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 and photograph some more. I don't take a lot of notes now when I go to site to do an audit. I walk around and I photograph and I photograph. Sometimes, if I leave it too long writing up, I go, what was that photo for? But then when I look at the photo, I can work out what it was, because every photo has a reason why you took it, and that gives you the thing. And it's so much easier. If you have to write at chainage 327 on the left-hand side behind the such and such, you've written about this much to write 2 lines of what the problem was. If you just simply say, see photo, it makes your audit report easier for you to write and a hell of a lot easier for the reader to actually understand. They don't have to play mental gymnastics about where in the design you're talking. And photographs are really good for post-construction. Sweet. For design audits, snipping from the drawings and slamming that in and then saying, here is the problem, really, 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 really helps you write the report and makes it
Excellent.
easier for people to understand.
Absolutely.
So yeah, prompt lists are hierarchical and they cover different things. So after a while, you can just sort of do walking and cycling, detailed design, and you don't have to remember all these bits, but it helps you go through. So that's the end of my presentation. I sped up a bit at the end. I hope I've made it on time, Ken.
You've done a beautiful job, Ferg, and lots of stuff in there. I think it's always important to remember that there is some real detailed technical knowledge to be undertaking these safe system audits, especially at those design stages. And Ferg's giving you a little window into that. I know some of this group are very technically sound. They're great technical experts. But I do say to others who maybe don't have that technical knowledge, it doesn't mean you can't provide a really wonderful input to a safe system audit. You just want to be in a team with people who have that technical expertise and knowledge, because they'll be looking at those very detailed, super elevation twists and these bits and pieces. And you can often provide those really logical questions like, well, hang on a second, how are pedestrians going to get from the McDonald's over here to the school over there, if that's those sort of logical questions, and combined we get that really nice mix. So thank you so much, Ferg. That is absolutely wonderful. I enjoy that every time, and I still have on my list to get that podcast going, and you'll be my first interview because we'll talk for hours on some of those different topics that we just scratched the surface of.
Okay, well, thank you, Ken. It's always a pleasure. Thank you, everybody, for listening. I hope it wasn't too hard and things. And I think just on that point that Ken was making, when we first started doing safety audits in New Zealand, Dr. Ian Appleton, who introduced the system, had this vision that we would actually take on an audit a driver, a member of the public, and take them on the audit team. It didn't work out that way because the ones they got fed up with people talking about warp rates and geeky shit. But having that somebody who knows nothing about design but can tell you, there's an old saying, if it doesn't feel right, find out what's wrong. And a great chunk of what we do in crash reduction studies and audits is, if it doesn't feel right, find out where it's wrong, because it will be.
That's it. And that common sense logic questioning is always wonderful. Now, I've got Ferg's contact details at the front of the slides, which you can download, or of course you can contact us and we'll put you in contact with Ferg. But if there's something that sparked a lot of interest you want to discuss further with him, please get in contact with him.
Yep, I love it. Thank you. Thanks, Ken.
Thanks, everyone. We're going to take a 3-minute break, and then we'll come back and I will give you a very important presentation around what you need to do for your big assignment. So let's take a break. Thanks again, Ferg. See ya.
See ya. Bye.
Got to make sure I record this. So anybody who misses it, this may be one you want to go back to it also and just check exactly what your requirements are. But the first thing I'll show you is just in the reference documents there, some of the things Ferg referred to, and I will put that the overtaking lane, passing lane study in here as well. But the Austroads Guide to Road Safety Part 6, Road Safety Audit there, that's the document that you can then go to, and you can see down here in the later pages, you have those prompt lists. Now, the prompt lists are there as per their name, just to prompt your thinking. They are not like a checklist that you would use and tick every box and then hand in. We don't want these as part of a safe system audit. They are simply there as thought starters, help you make sure you're covering lots and lots of things. They certainly don't cover everything you might find in every scenario. They've tried to be asking questions, general questions, other bits and pieces, but they don't replace you just logically looking at the site, the design, and making those calls. So that's the that's in there. Of course, you've got your Waka Kotahi Safe System Audit Guidelines that doesn't have a prompt list in it. So the Austroads Guide is the one you can look at there. So let's jump back a little bit, and I want to show you where you will be finding the assignment. Now, you're all very good at the learning management system, but you'll see here we're in module 5, and you can download a copy of Ferg's presentation there. What we have here is an example safe system audit report. Okay, so we've popped one in here so you can actually see what an actual safe system audit report would look like. That's for you to look at. Feel free to copy parts of it. We're not precious with any of that in terms of standard words and everything like that. Obviously, this one's for a particular site, but that will give you a nice bit of an indication of what a safe system audit actually looks like as an output. You'll see here that we have module 5 assignment, site inspection, and write your audit report. That's the big assignment. But below this, a couple of things that I want to flag right now is that you are going to have to agree to this safe work method statement, because what we're about to ask you to do is go to a local site. You've given us an address, and we've then found a site close to you where they are proposing to do some alterations, or some alterations have been designed to the road or street or intersection in that area. Now, we're going to ask you to go out there and have a look at it. The reason you're looking at it is because you're imagining this new thing built and how that will function, how it will operate, and what safety issues there will be for users in the future. But we want to ensure that you're safe. We have risk assessed each of the sites to make sure we're not sending you out to somewhere that's dangerous to stand around. So they're all low risk sites from that perspective. But they do require you to be sensible, to take some just basic safety precautions. So there's a safe work method statement, which you'll have to have a quick look at. And then here is a one question quiz, I suppose it is, just to say, yes, you will conform to that. Actually, I'll just click on it for you. You will conform to that safe work method statement. So things like you won't be intoxicated when you go out there, you'll wear your high-vis vest, and those sorts of things. So have a read of that, agree to that, and make sure you do wear your high-vis vest. There is no need to be out there measuring lane widths or anything like that. You're standing back just to observe. Okay, how do people use this area now? And what are they planning to build here? Okay, it's a cross intersection at the moment. They're planning a roundabout. And then you're looking, okay, oh, well, pedestrians seem to cross there. Is this going to make it worse for them to cross? How are bikes going to get through here? Is this intersection obvious for vehicles approaching? Those sorts of questions you'll be asking yourself, and you'll be trying to identify some of the issues. So then let's go into the actual assignment. And if you click on then assignment 5 there, you'll see you get some information in there, but you'll see this big lot of documents. Each one of the PDFs will have, or one of the PDFs will have your name and maybe some names of others in there as well. Okay, you need to find your one. It will be local to you. So hopefully you can identify that, find it, and then you will download that. I'm just checking there. Yeah, so if for some reason you can't find your name, or it's not close to you for some reason, please just email training@SafeSystemSolutions. Let us know. They will issue you a site, or they will change the site if it's a long way away. Like one of the questions in the Safe Work Method statement says, if you're driving for more than a couple of hours, that you'll take appropriate rest breaks and the like. If you had to drive for a couple of hours to get to your site, tell us. We'll get you a close site. So you'll download your design. You'll have a look at the design, and it will be something. What's this one? There we go. Okay. Oh, this one looks complicated. Okay, so putting a new median island in. That's a funky one. So this is a dog bone roundabout is what I would call this, which is where you can't go around this bit of it. It's sort of a large, it's an elongated dog bone roundabout. So you'll see in here that there's some information on the AADT, the amount of vehicles on different roads. Use this information in the safe system assessment part of it for your exposure. Even if you know different, if you say, no, I know Kennedy Road actually has 25,000 vehicles, use what is supplied to you, because our markers are just checking that you know that you've got to go to the scoring reference sheet. You've got to check what an 8,000 is. You've got to take that and say, okay, that's a 2 for exposure. So you'll get some information there. You'll get a design. So that currently does not exist or shouldn't exist yet. Occasionally they've built it in between us finding the design and you having a look at it. If it's built, just get in contact with us. You can still do the exercise. It's a slight little bit of difference. So you're imagining all of that built, and then you're undertaking your safe system assessment accordingly. So then you can see we've got, that was one design. I think that's but if we look at another one, who we go, Juliet, we'll see where you're going. So hopefully that's close to you. Okay, you can see this one, for example, is, again, it's got some information. Looks like they're signalizing this intersection that's currently unsignalized. And probably a good example of where, have a think about where you're going to park or how you're going to get there, and where you're going to stand. There is plenty of areas to stand away and park a car if you're taking a car out there in areas that are not going to impact on other traffic or not going to put you in danger as well, or push cyclists into dangerous areas or the like. Okay, so you find your design. You make sure you're wearing your high-vis vest when you go out there. And then you're going to have a look at the site in its existing form. You're going to look at your design, and then you're going to start working on your actual assessment. So you click on this Word document, and there's an Excel graph generator just to help you out. So the Word document here, let's have a look at that. So we've clicked on the Word document. It's the Safe System Audit template from Wakakatahi. We've just adapted it just a tiny bit for the training course purposes. So you'll be looking at a very preliminary concept style design. We have not given anybody detailed designs. That would just take you way, way, way too long. And we're just proving you understand the concept of what we're going through. But you are going to fill this out. And we've tried to help you here by highlighting in yellow things for you to fill out. So you see there's some standard words that are in all of these. So you just leave those words. You can have a read of it if you want to see what's in the sort of standard wording. Then you've got your risk assessment matrix, which you'll be using. And you can see here, this is where you're starting to add information. So what's the type of audit? Concept / preliminary design stage audit, team members. Now, this is going to have to be done individually. Of course, when we really do them, we do them as teams. We are okay if you recognize somebody else as going to the same site as you, has the same plan as you. You sort of work together. You can go out there together to the site. You can chat about it, obviously, but we will need to see 2 separate reports. One from each of you with your own findings and wordings. We don't want just one report from the both of you or more. You'll tell us when you went to site. In a real one, you'd pop in meeting times and those sort of things. So we've crossed out some of the stuff that we won't require you to do. You will not have enough context to really feel you're doing this comprehensively. Remember, it's a training exercise. You would love all the planning studies, lots of traffic data volume, turn movements, everything. You're not going to get that for the training exercise. You describe a little bit about the site here and the context with what you know and what you assume. You can give us as much as you understand in terms of what exists there and what they're proposing, what's the design. And then you're going to start doing your scoring. Now, you won't be able to fill 4.1, the section, out until you've sort of done all of your scoring. And then you'll come back and fill that out. And you'll put in there a graph as well of the outputs. Now, you only got one design option, so you'll be deleting a bit of that. And you'll be doing the matrix. Now, you've seen this. We've explained it to you. You'll do the existing conditions first. You'll fill out all this, make sure you're happy with it all. You'll copy it, you'll paste it, then you'll cross bits out of it, add bits for the design that you've got. And then we want you to write up just 3 specific safety concerns. So the Safe System Assessment Matrix will be done in full, and then you'll do 3 specific concerns that you'll take and you'll flesh out. You'll add in, the end risk rating you got, and how you got there. So unlikely, etc. Now, this is all standard Wakakatahi template stuff. You don't fill out the responses, okay? You leave all of that blank because that's for whoever you would, theoretically hand the report to do all of their responses. You'll be filling out this bit of information here and putting in those risk ratings. So you do it for 3 findings. Just do 3. I know some of you will find many issues that you want to talk about. Just do 3. If you do more than 3, the markers won't go beyond that. We just need 3 to prove that you've got a feel for how to write up an audit finding, how to risk rate it, how to provide some recommendations and categorize those. You write a little conclusion, and then the last thing we ask here is to take a photo of yourself at the site, wearing your high-vis vest, being very safe. Okay. Part of some of our requirements is that we know that you have gone to a site. You understand that you're looking at the value of going to a site to see the context, how it all works. So just prove to us. Just take a selfie of yourself out there on the site in your high-vis vest. You'll sign it, and that's just to make sure you understand the practice that we do sign our reports, and your safe system auditor in training. If you want to put a position in a company, you can. You don't need to do that. Okay, so once you've done all of that, then you will PDF it. So save as PDF, and then you will upload it to the site. Now I'm in teacher mode, so it doesn't have that upload option. Actually, I can just change that. I've got a second to do that. Switch role. Sorry, bear with me. Let's be a student. And so you've got all of that, and then hopefully, yeah, you go. So you've saved that, filled everything out, add submission, and then you'll be able to drop that submission in there or find it, and yeah, you'll submit that and it will be marked. Now, to create the graph, just to make your life a little bit easier, we just got this little graph generator. I mean, it's you could make this yourself in Excel in no time, I'm sure, but just to try to make life a little bit easier when you're doing the safe system assessment matrix, you can pop your numbers in and you can see it spits out your existing conditions, and then you can do your design as well. And then you'll be able to either just copy that or snip that and paste it in, just so you don't need to fiddle around too much creating the graph. But that's, so you're welcome to make your own, of course. So let's go back to the learning management system. You can see it opens today, or it's open now, but it is due on Thursday, the 21st of March. So you do have a bit of time for this, okay? So you've got some time. So my suggestion is you download your documentation pretty quickly, make sure you've got your head around, okay, where's my site? Is that convenient, or is that over the other side of the country? And if so, get that changed. Have I got the template? Okay, I can see that. Have I got the example one? Good, I've got everything I need. I feel comfortable be able to do this. And then ideally start going through that process, get out on to the site and start working your way through it. Because next session is a great opportunity to ask questions, to find out some specifics. If you're confused by bits and pieces, that will assist others, no doubt. If you're having a challenge, others probably would be having similar challenges. So we can discuss that. I can help with that, answer questions, guide you. Of course, anytime throughout this whole process, you can organize a one-on-one coaching session with an experienced safe system auditor who can answer questions, help you interpret the designs, talk to you about the matrix or the findings or how to report things, and really delve into that if you are having trouble. You also have 3 submissions, as in 3 chances to submit. So if you were to submit it and you didn't quite hit the mark, they would give you feedback and you'd be able to update it and have another submission. And if you're really struggling on that first submission, they will tell you that, or suggest to you strongly that you have a one-on-one coaching session with one of our experienced assessors to work through some of the challenges. So of course, anytime you need, email training@safesystemsolutions.com.au to get that, to organize that coaching specific session. Find your site, download the Word document, the Excel, and of course you will also be signing off the safe work method statement just to assure us that you'll be thinking about your safety when you're on the site as well. Okay, let me just check. I think I've covered everything. There is not a specific quiz for this module because you have this big assignment to do. There is a little bit of work in there. It's not just a quick sort of 15-minute exercise. You're going to have to spend a bit of time on this, but we need assurance that you sort of understand this process of safe system auditing. You're able to run through that. Of course, you know, we understand you'll be learning as you do it, and you'll be continuing to learn over time. So we don't expect you to be absolutely perfect from the get-go, but we do need that assurance of a base level of understanding of how all this works. Okay. Are there any questions for me? Okay, great. Thanks, Amin. There's a question in there about a nighttime site visit. So the answer to that is no. In fact, we don't want you going out there at night. Again, part of our risk assessment and risk management from an occupational health and safety perspective was a decision made that we don't want participants going out there at night. Okay, it might be just, you know, around the corner from your house and you go past there anyway and those sort of things. But as the official process, there is no nighttime inspection associated with this, just daytime inspection only. Thank you. Great question. Any other questions? Well, I'll remind you that any questions you do have, you can email them through at any point in time. Also, you can bring questions to our next session, where we will do some breakout rooms, and we'll get a little practice writing up some of these audit findings and the like, which is good. But if there aren't any other questions, excuse me. If there aren't any other questions at this stage, I'll give you 4 minutes back to download all of that information, and I will go about uploading that overtaking lane study. I think. Oh, just one more thing. So Ferg mentioned about taking lots and lots of photos, and I absolutely agree with that. And I think somebody popped into the chat to run a, you know, dash cam it. That's absolutely what I would do, and I always do as well. Is I either drive through with a dash cam with a team. We drive every leg, every direction, and capture all of that, so you've got that on record. Or I ride my bike through in all directions and with a 360-degree camera on or something like that. You want to do that just so you've got that exactly as Ferg said, if you need to go back to the site. But for this assignment one, we don't want any of that, all those photos or everything like that. Just one photo, which is you on the site. Okay. But in a proper one, you would put in some other photos. But for your findings, your audit findings, you might want to put a photo in. That's fine, or a snip of the design or something. In fact, we really encourage that, because that nicely helps a reader be able to understand what this issue is you're talking about. Fantastic. Well, thank you. Great session, and look forward to seeing you a few minutes before the next one for a chance to win a prize. But please do contact us. Don't sit there feeling overwhelmed by this task. Early on, email us. We will coach you. We will assist you through this task. Otherwise, get stuck into it. Thanks, everyone. Bye.